Let me now show you the simulation of the forward converter with lossless core flux reset. This is the entire circuit diagram of the forward converter with lossless core reset. Observe this transformer part. So in the transformer part you have three windings. One is the primary, other is the secondary, and in between you have the demagnetizing winding. So this demagnetizing winding is the one which will perform the core reset. I have this demagnetizing diode flowing into the source. I have here current sensors in the form of zero voltage sources. I'm sensing the IQ current by using a VIQ zero voltage source, VID zero voltage source for the demagnetizing current, and VIS another zero voltage source for measuring the ID1 current. Another change you will notice is in the values of L, 10 millihenry. I have also provided initial condition of 1.1944. Now this value I took from the simulation after it has reached steady state, so that the simulation can be quicker and you can see the outputs in less number of cycles. I have also given a voltage initial condition for the capacitance. These two are the states of the system, and therefore you need to provide the initial conditions for these two states. And I have given a voltage initial condition value here, again taken from the steady state value when, of the previous simulation that I did without initial conditions. Now in giving this initial condition, the simulation can be very quick, and you can directly look at the steady state and see the simulation for just few cycles, 5 or 6 cycles. This transformer here, forward converter transformer, when you double click, you will see that it is a sub-circuit. X, NP, the primary turns is 10, ND, that is the demagnetizing number of demagnetizing winding number of turns is 10, NS 20, and the permeance I have put it as 150. I have put it in electrical parameters of microfarad, but it is micro, 10 to the power of minus 6 in terms of the magnetic parameters. So we can now simulate it in ngSpice. Before we simulate it in ngSpice, let us have a look at the .cir file. So double click on the forward.cir file, and you will see that you have the trans statement for the transient analysis, the include statement, including the net file which will get generated from after having run the schematic to net generation command. Then in the control statements, I have here set background color to white, foreground color to black, run the simulation and plot. Now in plot, I am using output voltage V0 with reference to R. If you just put V0, it will be with respect to ground, and ground is on the primary side, and you need to see actually the V0 with respect to its secondary ground, which is the reference here in this case is R. So therefore you need to see V0 with respect to R, IL, the inductor current, and IVIS is nothing but the diode D1 current. So you can put in many other variables to see the various other waveforms, but I have just put these two so that you get started and then you include and explore on your own. Okay, now let us open a terminal window, command window, and run the simulation. So I have here the command window opened in front of me. I will run the simulation like before. I will use the run sim and forward. So this will run the simulation in the forward lossless and generate the output. As you can see, I have given it for very small number of cycles. You will see this as the output voltage VOR. Okay, so that's close to around 12 volts, and calculate it with the input, and then find out if by the input output voltage relationship you get approximately this value. Then you have this blue and this other one, the diode current and the inductor current. So let me probably expand it so that you get, I will expand it here and see. So this is your inductor current. So this is the inductor current and the diode current here. Okay, and this portion diode current is 0 and inductor current is falling. You can separately see these waveforms also, just to confirm whether your theory is proper. Anyway, I will allow you to explore the circuit, and you can try to change values and change the initial conditions, and also the change the value, redesign for different frequencies of the PWM, and try to get more insight into the workings of this forward converter with a lossless core reset.